Welcome to clickmyprojects.com. We are going to see the paper regarding a game-theoretic approach to the formation of clustered overlay networks. First of all, this paper comes under the domain of parallel and distributed systems. Distributed is concerned to network of computers physically which is being distributed in some geographical areas for handling multitasking. Not only for multitasking, data sharing and many things this distributed systems is being used. Now we are going to see the paper concept means we are going to focus on large scale distributed systems. That is, first of all, there is a possibility of in this paper we are going to focus on large scale distributed systems. Here nodes form cluster by creating logical links to other nodes that can share the similar content or anything else. Okay, so this thing is said to be clustered overlay networks. So what is the main reason for formation of such networks is nothing but to have the flexible data exchange with relevant to the queries. So that is the main aspect of the paper. Of course, we can use this paper. The traces of P2P systems indicated that nodes will be exhibiting certain properties which is of interest based on the locality. For example, if there is any request for a query, that query, the answer for the query will be retrieving from a particular cluster. So that is the use of the cluster overlay networks. First of all, initially all the nodes will be placed in forms of cluster, and afterwards if any query retrieval is happening, then the sufficient cluster that is related to the query is being retrieved at that particular instance. For that particular instance, we are going to handle the game-theoretic approach. The configuration of clustered overlay networks is modeled as a strategic games, as we told. Here, nodes will be determining the cluster membership cost for the actually the main concern is for getting them better network. That's the thing. On concerning the problem, all these things, why we are approaching this particular paper is for avoiding the dynamic maintenance issue. That is, in existing there is a lacking of dynamic maintenance issue. So in order to avoid all these issues, we are in need to have this particular approach. The chief thing in structuring of such clusters in cluster overlays is for facilitating their participants to discover and exchange data which can associate to the queries with very much less effort. Moreover, the issue lies in such settings efficiently to locate the users as well as the nodes for collecting the better peers for obtaining the required data for the user queries. So this is the main objective of this paper. Now we are going to see the flow of this paper. First of all, the flow starts with node generation and strategy formation. See, before this we are in need to estimate certain issues. That is, so node creation is the initial process, and after that we are in need to organize set of nodes. Then we are in need to have the data set such as routers, because using this data set only we are in need to organize the files for each and every nodes. That's the thing. And before those things we are in need to pre-process the data set for evaluating the queries. Okay, so organization of the files with respect to the queries, that is the next stage that is being done. And then the strategy formations. As I told, the strategy formation is based on the semantic phase, that is which is done based on the word net. Okay, and after that we are in need to classify the loads based on two aspects. That is, one is a global workload and another one is local workload. Each node establishes the logical link with other nodes, and then clusters are framed based on the similarity of the content. So for that particular purpose we are in need to have the connection with respect to the word net. That's the thing. And then nodes inside each clusters are highly connected with each other by having the intra-cluster communication based on the similarities, what I told. And after that, nodes is organized with the parameters such as content as well as queries. So two set of parameters is being used. And after that, in particularly saying each and every node chooses which cluster to join from set of cluster C is based on the strategy, some strategies. We are in need to adopt some strategies. Okay, how we are going to calculate the strategies? Based on the cost function. So this cost function is nothing but we are in need to estimate the cost, which is individual cost and social cost. Individual cost is framed by having certain nodes for choosing the strategy S. That is determined by having the cluster membership cost. and the recall cost. So we are in need to estimate these two parameters for evaluating the individual node cost. After that, we are in need to have the overall, that is utility function. Okay, so what is use of this utility function? That means it is nothing but it is going to give the individual piece contribution. Okay, so the main aspect of this is maximizing the cost, that is maximizing the query retrieval cost. That's finally, we are in need to have the cluster information based on 3 protocols, that is uncoordinated, coordinated, and partial knowledge. See, all these things, what is the purpose means, we are in need to estimate the content sharing, how much the cluster with respect to the content, how particular the content is related to the particular cluster. So that is the main aspect of this paper. And now we shall see the running procedure of our particular project. Thank you. You are in need to open the NetBeans and you are in need to start the WAMP server. Then click the setup 1.java and start running the project. Before that, you are in need to include the libraries also. So add jar folder and the jars which is being given, you are in need to add those jars. Then so first of all, you are in need to create the resources, that is nodes, right? So that is the thing that is being created, and then this is the node creation, and then extract attributes. Actually, what we are in need to give is we are in need to give some certain documents as input. That's all. So I have placed all those documents here in game file in input folder. So these are a set of documents in which you can select for giving the input in order to form the clusters. So I'm going to select 5 files. So as I have given 5 nodes, you can select 5 files, but it is better to select 5 files. Then upload, then pre-processing. So these are the steps. See, this one, the contents of each file is being displayed, and then the file is being splitted out, and then pre-process is done, and then extract. Total number of clusters is 5, and then query terms is being mentioned here, and then strategies. Similarity between each and every document is being computed. So this is the semantic part which is being done using the WordNet, and then clusters are formed. See, this is the cost for each and every strategy. These documents are being integrated, document 1 and document 13, and the cost for these two integration is given as 68. And then next is strategy formation. I've just clearly split it out and I've given you with respect to the cluster. Then we are in need to evaluate the further cost. So in this, for calculating the cluster cost, what we are in need to do is we are in need to estimate the the query cost also. That is, I may need to pass the query for this particular document. So I'll selecting Q11 as it is a query for these documents that is being selected. So the cost evaluation is done, and the strategies size-based configuration is done. Here is its cost with the balanced configuration, which determines the clusters. Then we are in need to form the recall cost, local workload cost, and then stability and optimality. After that, uncoordinated protocols is being performed. See, actually what is the use of this one is we are going to just check whether the framed strategies are good or not. So we are in need to select any one of the documents which is being selected previously. So I'm selecting this document, any nodes and coordinated protocol. So it is saying that as per coordinated protocol, this node can select yes 9. If it is an uncoordinated protocol, old strategy is good because the new strategy is having the value 0.0. That's it. There is no similarity between the document. That's why it is coming like this. And then similarity is also calculated, and an overhead is also calculated. Stopping, batching of events is nothing but changes which is being made as per the uncoordinated protocols with the query terms is also extracted. So these are the query sets that is being framed for each and every nodes, and this is the individual node cost after playing the game theory. So this is in this way it is being calculated. Thank you.